Alright, y'all, so in this video, what we're going to do is I'm going to show you guys the, DESMOS trick, kind of, to do this. Alright, so, first step, we want to make our graph less disgusting looking, right? So, to do that, we go up here to our little wrench. We're going to uncheck where it says minor grid lines, okay? And we change our step to 1. Alright, this way, oops, it nice and clearly labels just by ones, just 1, 2, 3, 4, 5, all that good stuff. It's a lot easier to read. You're not getting all those tiny little hash marks between our grids. Okay, so what we're doing, we are working on writing the equation of the line that passes through 2 points. So, first thing you want to do, this is a little easier on your computer, you can type the word table and it'll give you a table, or you can go up to this little plus button, click table, alright, and it's going to give you a table. And so in our first example, we're going to look at these 2 points, alright, 5, 4, and 2, 7. So we have 5 and 4, 2, and 7. Okay, we plot our points. Next thing, you can either hold down, oops, or it's not going to let me do it on my iPad, that's fun. If you have your, you're on your computer, you have your mouse, you can hold down on that button, or you can go to this little gear, click on that, click on your circle, change the color if you so desire. You're going to turn on lines, and you're going to turn on drag. Alright? Up next, you're going to plot an extra point. Right? So you're given your 2 points. Now you're going to plot a third point. Actually, before we do that, we're actually going to do our slope. Just kidding. So, we can look at our graph, and because we made it less disgusting, we can do our rise and our run. We can see that we go down 1, 2, 3. We went down 3, and then we went to the right 1, 2, 3. So if we look at our paper, we know our slope, oopsies, is rise over run. So we had -3 over 3, and that, sorry that this is so awful to look at there with the paper behind, with the screen behind it. -3 over 3, okay, and that's just going to simplify as -1, so our slope is -1. Alright, next bit, now, this is where we add our extra point. I lost my pencil. Big yikes. Oh, there it is. We add our extra point of 0, 0. Click on our table, 0, 0. And so this is why we added the drag feature. So what you're going to do, now that we have our slope, we can either drag our ordered pair and apply our slope, right? And then we go left and over to find our y-intercept. Or you can just kind of drag it around until you see what looks, about right. Okay, it's what makes a straight line. All of your y-intercepts are going to be whole numbers, so don't worry about 9 1/4, 8 3/4, anything like that. Okay, they're going to be whole numbers. Alright, so you can kind of eyeball it and see, alright, yep, that is going to give me a straight line. That tells me that my y-intercept is 9. Alright, so we put this together, we have that our y-intercept is 9. Okay, so now we use slope-intercept form, which I have listed right up here. Right, y equals mx plus b. And we just put this together. Our m is -1, and our b is 9. So y equals -1x plus 9. And if we wanted to check, in the other video I did this algebraically, and you see we got the same equation. Alright, let's do another one. We're going to do the same theory I did in the algebraic video, just so that way you guys are able to compare the two methods. Alright, so our next one, we're using these ordered pairs, -5, 5, and -1, 9. So we go to our table, -5, 5, -1, and 9. All right, settings, click on it, lines, and drag. Oops, I deleted my table. Ah! All right, let's try that again. So we have -5, 5, -1, and 9. Settings, lines, hello, drag, hello. All right, so we have our lines. We can do our rise and our run. But look, we're gonna rise 1, 2, 3, 4. Run 1, 2, 3, 4, 5. 1, 2, 3. No, just kidding. Rise 1, 2, 3, 4. Run 4. All right, so rise over run. Go to this. We have 4 over 4, which simplifies to just 1. All right, next up, we add our ordered pair, our third ordered pair. We add 0, 0, and now we drag. We just click on our point and we drag it. If we know our slope is up 1 over, we can up 1 over 1. And let's see. Oh, all right, perfect. Oh, not super perfect. We cross right there at 10. Okay, like I said, you can adjust it however you need. There we go. We can see it crossing right there at 10. So that tells us our B value is 10. And when we put this all together in an equation, we have y equals 1x plus 10. All right, last one that I'm going to walk through is going to be this fourth one down here. All right, with these ordered pairs that are both intercepts. So this one might look a little different than what you've seen. All right, so our first ordered pair is 0, 0, 5. Our second ordered pair is 4, 0. Give the screen a second to adjust. There we go. Settings. Adjust our points. Turn on lines and drag. I'm going to make this one orange. Change the color a little bit. All right. And if you ever goof on your graph like this, like I did, where it is just hideous, hit the home button and it'll readjust for you. All right. So if we look at this and we want to calculate our rise and our run, we see that we go down 5 and right 4. So we know that our m is -5 over 4. That will not simplify, okay? So it's stuck as a fraction. Do not give me a decimal. Decimals are disgusting. I want fractions. So that way we know to rise and run. All right? And our next step, this one's kind of optional in a way. So when we go to add this point for this example, because, oops, we already have our y-intercept on the graph, right? It already tells us that we cross at 5. So our b value is 5. So when we put all this together, we have y equals -5 over 4x plus 5. Okay. And if you double check this second equation, x plus 10, that's what we got when we solved it algebraically over here. Same thing with this third equation, the -5/4 x plus 5. Okay, it's really just a matter of what you guys prefer. All right, hopefully this helps.